Hey guys, welcome back. In this tutorial, we're going to be pairing up stocks from the SPY ETF and running some tests to see if they're good candidates for a pairs trade, and most importantly, testing whether or not the spread is stationary or mean reverting. If you haven't already, please go watch my tutorial on the pair trading package, as we will be using that package in the script. So load up all of these packages, and the first thing we need is to load up our stock data. Now, since we are testing multiple stocks in different combinations, instead of requesting the data multiple times, it's just better to load it up once. And I do have a tutorial on how to do that for multiple tickers, and I'll leave a link to that tutorial in the video description. But the output of that script saves all the data as an RDS file, which we're just reading back in. So I'll give you an example of what that looks like. So in our stock data frame, we have the ticker, the date, the open, high, low, close, and the volume each day for multiple stocks. So after we load the data, we need to extract the unique tickers from this data frame, which is done in line 18, and then just subsetting those tickers to the SPY constituents. And I'm running it this way just to double check that the data for the SPY constituents actually exist inside of my stock data. The next step is to make pairs of stock symbols. So I decided to go by using combination by passing in tickers and selecting 2 and returning that as a data frame. And what that looks like is just a data frame with 2 columns. So our pairs list is quite lengthy. We have approximately 125,000 different pairs. Now I did double check just to verify that we don't have the inverses. So as an example, this data frame doesn't have the inverse of this first row, which would be Apple in the first column and A in the second, which is nice as we won't have to make calculations for a pair twice. So in our backtest, we're going to use this data frame by passing in each pair into a function, which will return a data frame with results for each pair that we can later analyze. So back in the script, we're going to create that function called pairTest. Now, in order for this function to work, we're going to pass along 2 symbols, which will create our pair, along with a probability, which will be used to create bands for our spread by using quantiles. And I'll show you how that works later down the script. But essentially, we're going to take our spread, we're going to apply a rolling quantile on that spread, and hopefully we can use that as trading signals. When we pass in those 2 stock symbols, we're going to subset our stock data. We're going to convert those data frames as an XDS object, and we're only going to use the closing price. We're going to combine the 2. Next, we're going to use this function to extract our spread, and it's going to recalculate our hedge ratio by performing a linear regression every 20 days. After that's done, we're going to extract our spread. We're going to run this function to test whether or not the spread is stationary, and we're going to be saving our results into this variable called res. So we start off by using both symbols. We're going to add that test. Now in this next part, we're going to take our spread and we're going to calculate and return our quantile by using the probability that we passed in since inception. We're going to use roll apply, pass in our spread, and for 1 through all the number of rows in pair, we're going to use quantile, and we're going to extract the lower 10% and upper 10% of those values, and we're going to assign those as columns for our lower and upper values. We're going to add a new column for our signal, and the way we want to trade it is if the spread is above our upper line, we want to short it, and when it's below, we want to long. And hopefully up to this point, we have some signals, and now we need to fill in all the NAs by using NA LOCF. So essentially what we're doing is once we get a signal, it's going to remain that signal until the signal flips. And I'll show you a plot of what that looks like later down in this markdown. Now we're going to extract our results. How do we trade this strategy? Now from here, I'm going to separate the returns into 2 different categories. The first will be using our hedge ratio. Since it's performing a rolling regression, our hedge ratio is going to change each day, and we would need to make adjustments on the close, which I did not like because it would be costly to make the changes each day. So to mitigate, what I decided to do was to use 1 share lots instead of using our hedging. So whenever we got a signal, we would short one stock and long the other until our signal flipped. So we're going to be extracting the returns for both methods, and we're going to compare those results. So for these 2 different results, we're going to be extracting our total return, our average return each day, the max drawdown, and a ratio, which is just the average return over our max drawdown. Once we have added those to our data frame, we're just going to return the results. Now that we have our function built, we can pass along our pairs, and I have commented this out because as you see, it did take some time to run. And within this block, we're going to step into our combinations list. We're going to pass in 2 stocks and return the results. And you want to save this as an RDS file so that you don't have to rerun this each time. And once it's saved, we can go ahead and read it back in. Once we have all of our results, we can go ahead and subset and pick only stationary spreads. We're going to be sorting by our ratio, and we want to make sure that this ratio is above 0 and both stationary tests are true. And here we just print the top 10, and here we see that IBM and GEV had the highest ratio and a total return of approximately 48%. And this return is actually using the hedge method. So separately we have the no hedge total return. So had we not used the hedging ratio, this would have been our total return. And if we keep scrolling to the right, we will see our no hedge average return, the max drawdown, and our ratio. If we take a look at the results, you can pick any of these two stocks and pass them into our next block. So what I'm going to actually do is we're going to sort by our no hedge ratio, and I want to see the results for the second row. So I'm going to be passing in both of these ticker symbols into the next block, and we're going to go ahead and verify the spreads. So within the function that we have called pair test, I just copied the content from inside of that function and pasted it into this block. And instead of returning the results or the summary, we're just going to plot the performance of the pair and compare the hedged versus the non-hedged. Once you run this block, it will generate this plot. So here we see that the no hedged outperformed our hedge version. And just to verify, we see that the no hedged pair had a total return of about 120%. So if we go back to our pairs and we sort again, we see that the total return for the non-hedged was about 120% versus the hedged at 35%. So we do see that the returns are pretty accurate. Now the final thing I wanted to check was the trading signals. So here we're going to use high chart to plot our spread and signals. So the blue line here is our actual spread. The red line is our upper band. And whenever we have the spread crossing over this upper line, we want to go short. And whenever it crosses this green line, we want to go long. And we do see our signals as black bars down at the bottom. So for this particular spread, it looks like we don't have that many signals. And instead it has long streaks of signals. So here at the start, it looks like we were short. We were long from May 10th approximately all the way down here to July 16th. And that didn't change until October 1st. Now, preferably, I'd rather see more signals, as it could just be coincidence that one stock outperforms the other over longer periods of time. And having these long streaks of signals can be costly since we have to keep our short position for a longer period of time. So I'm going to go through the list of results, pick out a pair that I like, and in the next tutorial, I'm going to be building an algo that trades around this particular strategy on a paper trading account. And with that, guys, this concludes the video. Don't take this as investment advice, as we still need to monitor how this performs at a sample. And I'll leave a link down in the description area to my Patreon in case you want this script. Please consider subscribing to the channel if you haven't done so already. Thank you so much for watching, and I'll see you guys in the next video.